Hi everyone, my name is Tori Bauer-Pisani. Today's date is November 22nd, 2023, and I will be describing the cardiovascular cycle. So based on this diagram here, deoxygenated blood can enter through the heart in two different avenues. Through the superior vena cava, which is above the diaphragm, and the inferior vena cava, which is below the diaphragm. From these 2 points, blood will go through the right atrium, and the right atrium will lead to the tricuspid valve, where blood is pushed through the tricuspid valve and into the right ventricle. Now, from the right ventricle, blood is pushed to the pulmonary valve, which is also one of the semilunar valves because of its lunar structure, if you kind of look at it from a bird's eye view. And then it goes through to the pulmonary arteries. Now, in the pulmonary arteries, that blood is taken into the lungs where gas exchange occurs as we are taking waste gases like CO2, and then we need to exchange them to have oxygen-rich blood in order to rejuvenate the tissues. So from the pulmonary arteries, blood is moved into the smaller arterial structures, which are called arterioles. And then from the arterioles, blood will go through to the capillary beds, where the capillary beds are exchange CO2 to oxygen. From the capillary beds, the blood will pass through to venules, which are very small venous structures, and then to the pulmonary veins. And in this diagram, the pulmonary veins are right here, and that is where our oxygenated blood will first come through back to the left atrium of the heart, where blood is pushed through the mitral valve and into the left ventricle. And through the left ventricle, blood is shunted upward towards the aortic valve, which is the other semilunar valve, and into the aorta, where their blood is oxygen rich and will go through all the tissues of the body, and then we'll go through the cycle again and again. The one thing that I did want to mention is in relation to blood pressure. The way that we measure blood pressure is by taking the systolic over the diastolic numbers. So in relation to the cardiac cycle, our systolic blood pressure is taken from the pushing of the oxygen-rich blood during the contraction of the cardiac cycle. And that is when blood comes back through the pulmonary vein into the left side of the heart, which is the left atrium and the left ventricle. So, and that is why we have a thickened side here of the cardiac wall, where we have, more muscle mass is able to push more, a higher pressurized blood up through into the aorta. And then for our diastolic pressure, that would be when the heart is relaxing, or there's a cardiac filling, as we call it. So over on the right side of the heart, where we have a thinned muscle wall, when blood fills from the right atrium and into the right ventricle. And that is how we measure pressure, and that is how we also will go ahead and measure cardiac output when it comes to our, at least in my case, our really sick animal patients that come in that have really low blood pressure due to shock, or really high blood pressure due to shock, and then we will treat the cardiac output based on that. So I hope you enjoyed this presentation. I really enjoyed it. The cardiovascular cycle is complex, but it's extremely important to learn. Thank you.